My teammates and I on the Intergalactic Design Team here at UCSB have developed a new and improved fuel canister stabilizer. This is a device designed and proven to increase the safety and versatility of water boilers for campers or backpackers that have to cook on uneven surfaces. The two most popular stands in the current market are flat, foldable tripods, and these were our benchmarks. The problem is that on an angled surface, even a slight nudge can topple the jet boil containing all the boiling water, which is obviously a huge safety hazard.
To determine if safety and stability were actually as important as how lightweight and compact the design was, we interviewed some UCSB Excursion Club staff members and some friends who often camp and backpack. We received overwhelming support of our hypothesis that users are willing to sacrifice some good qualities like an extremely lightweight and collapsible design for increased stability and safety. Based on more in-depth interviews in which we obtained feedback on ways to design our product, and then using tools like the Gaucho hat approach and pew charts, we generated a list of needs. The device should be stable, compact, lightweight, adjustable, and easy to use.
Our new and improved stabilizer design is essentially a tripod with adjustable legs that can account for uneven surfaces and terrain. Each leg has the same general components of a human leg: a foot, shin, and thigh. The foot is the point of contact with the ground and has ridges on the bottom to increase friction and prevent slipping. The ankle attaching the foot to the shin can rotate, which allows the foot to fit to a variety of different angled surfaces. The shin of each leg also rotates at the knee, much like a human leg.
The leg should be able to lock in place in order to safely hold the fuel canister in boiling water. In order to accomplish this, there's a locking mechanism connecting the shin and thigh that includes two ribbed washers. The user can push the rod in to disengage the washers so the shin can be rotated to the desired location. Once it is correctly aligned, the user can release the pin, and a spring will push the shin back up against the side of the thigh, which re-engages the washers. The top of the thigh attaches onto the fuel canister by holding the base of the canister in a groove. Once all the legs are attached to the base of the fuel canister, the hose clamp at the top is tightened in order to keep the legs together and make sure they remain secured to the canister. Lastly, to increase the grip on the canister, rubber supports were glued to the top of the thigh.
To test how our prototype matches up against the benchmarks, we took them both out to the lagoon. One of our first prototypes clearly demonstrates how our design can adapt to uneven surfaces by adjusting the heights of the 3 points of contact. The benchmark, not so much. Our design also safely supports the boiling water on an inclined surface. The benchmark, on the other hand, did not hold up so well and revealed how unsafe and simplistic its design is. The main priority of our design was stability to increase the safety, but we also designed it to be light and able to easily collapse. The shape of the U-channel is key to limiting the weight because it decreases the amount of material, and the legs can effectively collapse and come back for storage.
After creating and testing our prototype, we revisited our list of needs. We determined that our final prototype met all the needs of a stable, collapsible, lightweight, adjustable, and easy-to-use design. Though this led to an effective prototype design, there are still many areas of improvement for future products, especially before introducing our design to the market. One of the main improvements needed is a more streamlined manufacturing process and a clear assembly procedure. The success of this design was due to a great collaborative and joint effort among all team members of the Intergalactic Design Team in creating a product that is truly out of this world.